Kia ora koutou. Today we're looking at the Snedmaths Practice Exam 4. I'll put a link to this exam in the video description so you can do it as well. The best thing to do is to pause it as a question is shown, have a go at doing the question yourself, and then once you've done that, check with what I've done to see if your answer is correct. You might just want to skip through and just check the answer if you know what you're doing. If you've struggled, then watch my working to see how I did it. So question 1. So this question asks us to write an expression for the volume in terms of the radius r, which means that we want something, the volume V equals, that's an expression for the volume, and the expression over here will have an r in it. That's what this in terms of means. So we need to look at our cylinder and say, well, what is the volume for our cylinder in terms of the formula for that? So let's have a look at our formula sheet that they give us. In our formula sheet, on here we have to find the cylinder. There will be one. There it is there on the right hand side. It says that the volume of a cylinder is pi r squared h. Volume equals pi r squared h. Now there's some information in here that we need to use. It says here that the cylinder is twice as tall as it is wide. Twice as tall as it is wide. So if it has a width of x, it has a height of 2x. So let's look at that x and 2x in terms of our formula pi r squared h. R is the radius, so the radius is there, so x is 2 times the radius. And our height is 2 times x, so our height must be 2 times x, which is 2r. So our height must be 4 times the radius. So if we go back to our formula over on the left hand side, our volume now equals pi times the radius squared times the height, which we've worked out to be 4 times r. And now we need to simplify that because the question does say to simplify it where possible. So if we simplify that, the volume equals 4 pi r cubed. And that's our solution. And that's a straight up achieved question. Let's look at 1b. So a rectangular poster has dimensions 40 by 60 centimeters. Just make a note of that. We've got centimeters. Any question with units must have units in the answer. A uniform border of width x is left blank around the image poster. We need to write an expression for the area of the image in terms of x. So this is the same as this first question. We've got this in terms of x. Our answer is going to be area equals some expression that will have an x in it. So the image itself is not given in terms of size, but the frame is. I'm just going to add a couple of things here. They've told us that the gap here is x between the edge of the frame and the image, and they've said here that it's a uniform border, which means it's the same all the way around. So this side here is x, this piece here is x, and above the image is also x, which means that the image itself, this distance here, is 40 centimeters minus those two x's, one above and one below. And then this length of the image is going to be the 60 centimeters from up the top minus the two x's, one on each side. So our area of a rectangle is a length times a width. So it's going to be 60 minus 2x times 40 minus 2x. Now that's actually correct right there like that. You get an achieved mark for that. However, you should always try and simplify it. You're not going to get it wrong if that's what you had to do and you expanded and simplified wrong. But if you did need to expand and simplify it for the answer and you stop there, then you've got a problem. So I'm going to expand that out. We do the first, and then we do the outside, and then we do the inside, and then we do the last foil. So area is going to be 60 times 40 plus negative 2x, sorry, first and then outside. So the outside is 60 times negative 2x, and then the inside negative 2x times 40, and then the outside negative 2x times negative 2x. So that will give us, we'll pop it in our calculator. Let me just go back on this calculator where it should be. 60 times 40, 2,400. And then we've got 60 times 2x times negative 2x and 40 times negative 2x. So 60 times negative 2, you obviously shouldn't need a calculator for that. And 40 times negative 2, we'll put those together, gives us negative 200x. And then negative 2x times negative 2x is plus 4x squared. Now, in the marking schedule, you would actually get it correct for there or for there. Let's have a look at 1c. It says, find the perimeter of the triangle shown in the diagram. So what makes this difficult is, first of all, we need to know what the word perimeter means. So perimeter is the distance around the outside. So that means that I need to know what is the distance if I add that side to that side to that side. But we don't know any of these lengths. So we have to calculate each of them. It's not immediately obvious what we need to do. However, if I look at this in a bit more detail, I can see that what I've got are some right angle triangles. If I look at this line first of all, I can create a right angle triangle like this. And it has 3 on that side and 4 on that side and an unknown on this side, x. So I can do my Pythagoras work that I know how to do. And if you remember, if you were in my class for Pythagoras, we said we need to create squares. Like that. So the square at the bottom will be 3 times 3, which is 9. The square on the left is 4 times 4, which is 16. And the top square, because it's the long side, will be 16 plus 9, which equals 25. So x will be the square root of 25, which is 5. I'm just going to pop a 5 in there because I know that's that length there now. All right, I'm going to just rub out a few things here and then show you the next step. I'm just going to rub out all that green. So if we now look at this side, sorry, I'll go back to the green color. If we now look at that side, I can create a right angle triangle up here, which has one side 3 and one side 4, and I'm trying to work out what this side is. And I can use the same method. What I'm going to do though is, because some people won't have done it with the squares the way I do, I'm going to do it using the a squared plus b squared equals c squared. But it's the same calculation, and in fact it's the same triangle. It's a 3, 4 and something triangle. So it's 3 squared plus 4 squared equals c squared. So 3 squared is 9, 4 squared is 16, so together they're 25. So c equals the square root of 25, so c equals 5. So that calculates that side to be 5. I'll do a quick bit of erasing again. And the third side, I can make a right angle triangle there where it has two sides of 1. So the squares that it creates are 1 and 1. So this square must be 1 plus 1, which is 2. So x is the square root of 2. Now that's not an easy square root to do, so we'll jump into our calculator and we'll do the square root of 2, which is 1.41. So the perimeter equals 5 plus 5 plus 1.41, the three sides together, which is 11.41. This does not have units in the question, so it does not have units in the answer. And according to the marking schedule, pretty much if you get any one of these three sides here with some working, and it could be showing that you're doing it with the squares like I do, or it could be that you're doing it with that calculation there. It doesn't really matter. So long as you're showing that you've got some working, then you get an achieved mark, and getting that together is a merit mark. I think that's a relatively straightforward merit question, and you'd be pretty happy if you got one like that in your exam. Let's have a look at question 1D. So 1D, this involves bearings. Now, bearings are no longer in the Year 11 curriculum. Some teachers say that it should be knowledge you know from Year 10, so you should know how to do it. I'm not sure that that's correct, but just for completeness, I'm going to do this question anyway. So the way bearings work, if I look at this up here, it says a bearing of 32 degrees. That means if I take the north direction, a bearing of 32 degrees means something in that direction with an angle of 32 degrees from north there. So bearings are always calculating the angle from north. So that means that in my diagram here, I need to add a north line, and then I can see that this part here, S1, is 32 degrees, and from that line that I made around to S2 is 80 degrees, which means that the smaller angle in here, if we need it, and I don't know if we will just yet, is 48 degrees, that 80 minus 32. So we need to find the distance between the two ships. So that's the distance from here to here. So that's an interesting one. We know that the length of these lines are given. They tell us that this S1 is 2 kilometers and S2 is 3 kilometers. I'll just put that in a bit of different color because my picture's getting cluttered. So the next thing I'm going to do is I'm going to drag these triangles out and I'm going to calculate some things on them separately. So I'm going to look at the triangle that has A and S1 in it. So it's got one line here, that's a right angle, and so this is point A, this is point S1, and we know that this length is 2 and this angle is 32 degrees. From there, I want to calculate what the distances are vertically and horizontally, because I think I'm going to need these. Like I say, I think this question is a little bit beyond what you need, but that's all right. So let me just label this as a SOHCAHTOA problem, because that's what it's going to be. That must be side H. Next to my angle is side A, the adjacent, and the one not connected is my opposite. So I want to find, first of all, the adjacent side. So I'm going to pop an X there. That means I'm not using the O, which means I've got A and H. So this is a car problem, C-A-H. I do my formula pyramid, and I put into my formula pyramid the things that I know. So A is X, H is 2, and C will be cosine of the angle, which is 32 degrees. And from there I can write my formula. X equals cosine 32 and 2 are next to each other, so that means that they're multiplied. And so X in this case equals, so I can put that in my calculator. I need to do cosine Your calculator would put brackets in there, so I'm going to do the same. Make sure you close your brackets or you'll end up with a wrong answer. Cosine of 32 times 2, and it gives me that that is 1.696, and we're talking kilometers because that was what the question said. I've done that now, so I'm going to go back into my drawing. I'm actually going to draw the triangle again because that's always the way to avoid making mistakes. So the things that I know is that this was point A, this was point S1, this angle is 32 degrees, and that's a right angle, and I want to find that, and that distance is 2. So in this diagram, I've got H there, again next to my angle is A, and opposite my angle is O, and I'm trying to find X, so that means that A is not used. So for this calculation, it's SOH. Construct my formula pyramid, put in the things that I know. Where O is the X, I've got the sine of 32 degrees, and H is 2. So X equals sine 32 degrees times 2. Put that into our calculator. Sine 32 degrees, close brackets, times 2. And I get 1.060 when I round that correctly. I just want to quickly show you why I keep saying you have to close those brackets. If I do sine bracket 32 times 2 like that, I get a very different answer because what it's actually done is it's done sine of 64 because it's done the 32 times 2 first and then done sine of that. So you've got to be really careful that your brackets go around the angle correctly. Alright, the next thing I'm going to do is the same calculations for our second triangle. So our second triangle looks like this. This angle here is 80 degrees. This distance is 3. That's my right angle there. Just going to separate those off. So I need to do exactly the same thing. And you probably worked out that I can pretty much copy my working from the left-hand side. Just make sure I copy in the values correctly. So A is X, H is 3, and I've got the cosine of 80 degrees. So X equals cosine 80 times 3. So the X distance there, the vertical distance is 0.521 kilometers. Actually, I left my units off that answer down there, so let's do that. And then my second one, so the horizontal distance, I want that there, labeling my triangle H, A, and O. A is not part of it, so I've got a SOH for my formula pyramid. O is where X is, H is a 3, and I've got sine of 80 degrees, so X equals sine 80 degrees times 3. So X is, I'll calculate that, X is 240 kilometers. That's not right. I've made a mistake in my calculator. I didn't actually press the sine button, it looks like. You need to be aware when you're doing your work of any time that an answer doesn't look right. I knew that 240 kilometers couldn't be right. Okay, so I've now got a few more distances and values there. What does that actually look like in terms of S1 and S2? The easiest thing to do for this is actually to draw effectively a Cartesian plane. I want to find the distance between the two ships, and then I want to find the bearing from S1 to S2. So there's a couple of things to do here. So the distance between the ships, let me just show you what I've calculated. I'm going to draw I'll move it over slightly. I'm going to draw here effectively like an XY plane. So this is my X-axis and this is my Y-axis, because this is the easiest way to think about it. This point, the origin here is point A. So S1 is up here and S2 is over here. What I've calculated by doing this is I've calculated the coordinates of S1 and S2. So when I calculated for S1, the 1.696, the first calculation, that was my vertical distance from A. That was the distance this way. So that is my Y value, so 1.696. And my X value was my second calculation, 1.060. And I did the same for S2. So S2 is at that point there. I've now got something where I can create a right angle triangle. If I connect those 2 points up and I put a vertical line and a horizontal line, I've got a right angle triangle, and I can work out these distances. The distance vertically is the large Y value minus the small y value, so 1.696 minus 0.521. So this side of my triangle is 1.175, and the bottom of my triangle is the distance between the X values, so 2.954 minus 1.060. That is 1. I'm running out of room here, 1.894. So I've got lots of information now about these triangles, which can be useful to me. So from that, I've got a right angle triangle. Let's copy that down here. One 1.175 and 1.894. So the distance between them I can find using Pythagoras, which we did in an earlier question, so I'm going to do that nice and quick. You can either do it using this method or using the squares that I would normally do in class. So 2.23 kilometers is the distance between them. I also need to find the bearing. So the bearing is going to be the angle from north to S2. The easiest thing to do here is actually just to work out what angle can I calculate straight away. And I can calculate this angle here. I'm going to put a little X on it and that little triangle that I've created. So this is a SOHCAHTOA problem, that's H. Not connected to the angle is O connected to the angle is A. I'm not using an H in this, so this is a TOA problem. Fill in the things that I know. So O is 1.894, A is 1.175, and the angle is tan of x. So let's write that down. Tan of x equals, and because these two things here are on top of each other, that means it's a fraction, 1.894 over 1.175, and we're finding an angle, so we need to do an inverse tan of that. Pop that in the calculator. 1.894. Oh, where's my fraction gone? And it's 58.2 degrees. And that was the angle marked X in my triangle. And the angle that I actually want is this angle here, which is going to be 180 degrees minus that. So the bearing equals 180 degrees minus 58.2 degrees, which is 121.8 degrees. Actually, you should always do a calculation like that in your calculator, just to be sure. Don't do it in your head. Alright, so then I would, just to finish this off, because it's a complicated question, I would write a sentence. The distance is 2.23 kilometers at a bearing of 121.8 degrees. And they've said that's a merit question. I think probably that's a little bit much for a merit. They've said that any two correct distances, so I calculated distances up here, any two distances here would be enough for achieved. Let's go on to the next question. So question 1e, a rectangular block. So the first thing to do is to get your head around the problem. At the bottom here it says find the percentage of the surface area that has been reduced. That's the key there. So I need to find what is the surface area of the block at the beginning, and what is the surface area once it's been reduced. What is the surface area at the beginning, and what is the surface area once it's been reduced? They've given us the net for the reduced one, but they haven't given us the net for the full block. So I'm just actually going to draw the net for the full block as well. So that's the net drawn there, and I've deliberately done it just above the existing one, so we can try and kind of match things up here. So sometimes it can be difficult in our heads to turn an object around, but let's just have a look at the things we're given. We're told that we've got an 8 centimeter and a 12 centimeter on the angled faces. And so if I look over at my net, I think the 8 is there and the 12 is there, and that 12 is going to match to that one there. This side X is going to be here and here. 15 is the height of this thing all the way across. And we know that the two sides here, 20 and 20, live here and here. And that this shape on the top is identical to the one on the bottom. So I'll just put those values into that as well. If we look at our diagram on the top here, we can, I can add some more things. The 20 on those side pieces matches to there and there as well, those two 20s there when we fold it up. So let's put these values that we know onto our net at the top. That's going to be 20, 20, because it's a square, that's 20, and that's 20. That's just a terrible scale drawing. We know that this is 20, this is 15 here, and this is also 20. So once I've drawn that, I can see that actually the surface area for the original cube is pretty straightforward. I've got two squares, and I'll just draw them over top of them here. One there, and another one here, which are both 20 times 20. So surface area of original, I'm going to write it like that so the marker knows what I'm doing, is going to be 2 times 20 times 20. That's those two pieces there. And I'm going to add to that the area of this whole middle rectangle piece. So that's going to be 15 times, I've got 4 lots of 20, which is 80. So the surface area of the original cube is going to be 2 times 20 times 20 plus 15 times 80, which is 2000. And I should check my units. I've got centimeters in the question, so my units are centimeters squared. If you have units in a question, you must have the units in the answer. So if you do that, you've already got yourself an achieved mark from this question. The question is, what has been removed? How much has been removed in my surface area? Well, the surface areas that have changed are my two end pieces or side pieces and those three things in the middle there. So there's 5 areas that have changed. This other rectangle here is very straightforward. We know that's going to be 15 times 40, and we'll deal with that later on. So let's have a look at what's changed. What we need to find out is what is the length of x, because at the moment we don't know the length of x. So how much has been removed? I'm going to take a triangle here. My triangle is going to be that shape there. And I'm going to draw that separately. Here's my triangle. It's a right angle triangle. They always give us right angle triangles. Now, on the left-hand side of my triangle, it was 20, and they've now got 12 there, which means I've got 8 left. And on the top of my triangle, it was 20, and I've got 8 left, so it must be 12. And I want to know what x is. This is a Pythagoras problem, and we've already done several of these in this exam. So you could do that with squares, where that's 12 times 12. You'd put that in your calculator, find 144. That's 8 times 8, which is 64. And so you put those in your calculator, 144 plus 64. So you get that square there is 208. And so x equals the square root of 208. Which is 14.42. So now I can go and look at my original shape and think, well, what do I need to know here? I can actually shape 3 and shape 5. Shape 3 and shape 5 in here are just part of a rectangle that already exists. So I could say that my rectangle there has got a 20. If I look at the bottom side, 20 plus 8 plus 12 plus x, which I now know is 14.2. So this whole length here is 20 plus 20 plus 8 plus x, which is 14.42 plus 12. That whole side there is 74.42. So the surface area of the reduced block, I'm just going to work on the middle rectangle, and that equals 15 times 74.42. Which is 1116.3 centimeters squared. Now, if I can calculate the area of one of the side shapes and multiply that by 2, I've got my answer. So I'm going to draw those. To find the area of this shape, we need to think of it as uh, a compound shape that comes from a rectangle with a triangle subtracted from it. So the area of the rectangle is 20 times 20, which you should be able to put into your calculator if you can't work it out in your head, 400 square centimeters. And then the area of the triangle, which is here, it has one side of 12, one side of 8. If we go and look at our formula sheet tells us that the area of a triangle comes from half times base times height. There it is there, top left. Half times base times height. So the area of that triangle is half times the base, which is 12, times the height, which is 8. .48. So the area of the shape is 400, the rectangle, minus 48, the triangle, which is 352 centimeters squared. So the total surface area of the reduced shape is 1116.3. That was the area of our middle rectangle, plus 352 times 2, because there's two of those shapes. Which is 1820.3 square centimeters. It's really easy at this point to assume you've finished the question, but when you have a question with lots and lots of steps in it, you should always go back and double check. And when I go back, I can see that a really key word in the question is the word percentage. A really key word is the word percentage. So it tells us we need to find the percentage that the surface area of the block has been reduced. In the marking schedule, it actually doesn't do this as asked. I read that as I need to know what is the percentage that it has been reduced by, not what is the final percentage of the original. But either way, the calculation is the same. It's just whether we do one more step. So the final surface area is 1820.3. I should actually just tell the marker what I'm doing. Percentage reduction. It's always good to tell the marker what we're doing. 1820.3 divided by 2000, and we're going to make that a percentage, so we're going to times it by 100. And I get 91.02%. Now that's the percentage that the last one is. I think if you did that, you get excellence. To fully answer the question, it's actually not been reduced by that amount. That's the percentage that's left. It's been reduced by what's left over. So the reduction reduced to 100 minus that. So we'll go 100 minus 91.02, and it's 8.98%. There's a lot going on in this question. It's a very, very complex question. In order to get some marks, I think I said earlier, you would get an achieved mark if you basically found the surface area of the original block, or if you found that value there, because that's another achieved skill. To get a merit mark, you would need to do something like finding the area of a complex shape, so that's at 352 there, and then to get excellence, you would need to get the percentage correct as well. on to question 1F. So this question looks quite complicated, but when you strip it down, this formula that they give you here for the area of a sector, which is actually something we do in year 12 maths, is not really required because the sector that they've given you down here is actually a quarter circle. So you only, because of this right angle in the middle of it, so you really only need to know that the area of that will be the area of a circle divided by 4. Essentially, uh, coming out of this formula here, the x is 90 and there's a 360 on the bottom, and that fraction simplifies to be a quarter. So I'm going to ignore that area formula they've given us because I can see that there's a better way of doing it. So we're trying to find the inner radius r, and we know that the area of the shaded part is 2 pi meters squared. So let's have a look at the area of a circle. So if we go to our formula sheet, it has the area of a circle on there. If we go down there, area of a circle is pi r squared. So the area of the full circle with a radius of 5 meters, let's call it the big circle, is going to be pi r squared. So that's pi times 5 squared, which is 25 pi. I'm just going to leave my answer like that because up in the question, oh sorry, I've just realized I haven't done that while you could see it. So I've just said this 5 meters here, the area of that big circle is pi r squared, so pi of 5 squared, which is 25 pi. And I said I'm just going to leave that like that for now in terms of leaving the pi in it, because up here the question told me the area of the shaded shape is 2 pi, so it might be easier to work with the number pi still in there. So that's the big circle, and we need to divide that by 4 in order to get the area of just that quarter part. So let's put a divide by 4 on each line there. So the area of the big circle is 25 pi over 4. And I can just leave it like that. If you wanted to, you can calculate that and have it as a decimal. So we would have 25 times pi over 4. And this calculator gives you the same thing. 19.63 meters squared. It tells us that the shaded area is 2 pi, which means that the area of the small space, so I'm just going to put that in green here, the area of this is the area of the big quarter minus 2 pi. So the area of the small must be 25 pi over 4, because that's the area of the big shape, minus the shaded area, which is 2 pi. And I can do that in my calculator. I can go and it gives me 17 pi over 4. If you're working in decimals, then at that point you'll get 13.35. So 17 pi over 4 is the area that I've got there, and I want to find what r is. So the area of that is the area of the small circle was equal to pi r squared. Let's use the capital R that they've got there, divided by 4. And I calculated that to be 17 pi over 4 equals pi r squared over 4. So what I've done is I put into here that value there. So 17 pi over 4, just tidy that up a bit, it's a bit hard to read, equals pi r squared over 4. Now they're both over 4. So if they're both over 4, then 17 pi must equal pi r squared, because if the denominators are the same, the numerators must be equal. So 17 pi equals pi r squared. What I'm going to do is I'm going to divide both sides by pi, because I want to find out what r is on its own. And what we find is that those actually disappear. So 17 equals r squared. If I want to find out what r is, I'm going to take the square root of that. So r equals 4.123 meters. Now you can see in here why I decided to keep my answer here with a pi in it, and again on this side with a pi in it. It's because when I got to here, they cancelled out. That's a little bit of knowledge I had. If you didn't do that, you're just going to be working with decimals, and that's totally fine. You're still going to end up with the same answer. In terms of what you get your grades for on that, you're going to get an achieved mark if you get to this point here. You're going to get a merit mark if you get to, if you're going to basically bring them together. So somewhere where you get to about here, it's slightly ambiguous in the marking schedule, and you're going to get an excellence mark if you get to there. All right, so on to question 2. So the first question is inequalities. I talked about this in the one I did yesterday. This sign here, less than or equal to, means for what values of x is this expression, expression 1, less than expression 2. So for example, if x was a 1, then expression 1 would be 2 times 1 plus 7, which is 9, and expression 2 would be 4 times 1 plus 17, which is 21. So this is true because 9 is less than 21. So when x is a 1, expression 1 is less than expression 2. If I was to choose a different value there for my example, let's say I chose what happens if x is negative 5, I would get 2 times negative 5 plus 7 on the left, 4 times negative 5 plus 17 on the right. So 2 times negative 5 plus 7 is negative 3. 4 times negative 5 plus 17 is also negative 3. Those are equal to each other, and my inequality sign said less than or equal, so this also is true. Let's say I tried negative 10 as my example there. 2 times negative 10 plus 7 on the left, 4 times negative 10 plus 17 on the right. So on the left we would have negative 13, and on the right we would have negative 23. So in this case we've got negative 13 and negative 23. If we think about a number line where we have 0 there, if that's negative 10, then negative 20 is there, negative 13 is somewhere here, negative 23 is going to be somewhere there. So this is bigger than this, and so the expression 1 is bigger than expression 2. So when x is negative 10, it is not true. So what we actually want to calculate is what are all of the values of x where expression 1 is less than or equal to expression 2. So let's clean this up and start calculating. The rules for doing linear inequalities, in fact any inequalities, are the same. Anytime you divide or multiply a negative number across from one side to the other, then you have to flip the sign around. So let's get into this. This is the way most of you will probably do this kind of question. 2x plus 7 less than or equal to 4x plus 17. Moving the x to the left-hand side is the way that most of you will do it. So now I'm dividing by a negative number as my last step to get rid of this negative 2. Because I've divided by a negative number, as I said before, the rule means I need to flip the inequality sign. So any value where x is greater than or equal to negative 5 is going to give me expression 1 being less than or equal to expression 2. And we kind of found that before. When we used negative 5 as an example, we found they were equal. When we used a number bigger than negative 5, then the left-hand side was smaller. And when we used a number smaller than negative 5, we found that the left-hand side was bigger. And that's a straight-out achieved question to be able to do that. Let's go on to 1b. A straight line passes through 1, 5 and 1, 4. And we need to find the equation of that. And we need to write the answer in this form that we're not really used to seeing, because we normally always see the equation of a line as y equals mx plus c. So this is slightly different. Let me take you through it. So I'm going to use the same technique that I normally would. They've given us a bit of space for working here, so I'm going to use that. I'm going to just do a quick Cartesian plane, x-y axis. So there's my x and my y. And so I've got 1 point at 1, 5. So 1 on the x and 5 on the y is about there. I'm just sketching it. It doesn't have to be exact. And then 4 on the x and 1 on the y is about there. And so I'm looking for the line that connects these 2 points. What is the equation of that line? So I need to know rise over run for my gradient. And I need to know a y-intercept, but we're going to calculate that through substitution. So the gradient equals rise over run, which in this case I can see my rise, it's going from 1 in the y value to a 5 in the y value. So my rise must be 4. And in the x value, it's going from a 1 to a 4. So that means that it's gone 3. So my gradient is 4 over 3. And I'm going downhill. I always need to check uphill or downhill, and it's downhill, so it's a negative gradient. So my gradient is negative 4 over 3. Now, I can work with y equals mx plus c to find out my next step. So remember, m is my gradient. So this value here is going to go in where m is. To calculate c, I can take either of the 2 points I've got. So I'm going to use that one there, and I'm going to take the x value and substitute it in for x there, and the y value and substitute it in for y there. Grab my calculator to find out what 5 plus 4 over 3 is. 5 plus, and it tells me it's 19 over 3, so c equals 19 over 3. So my equation then, now that I've got an m and a c, is y equals negative 4/3 x plus 19 over 3, or 19/3, which is the equation, but it's asked for the equation in the form Let me just rub out some of those. It's asked for the equation in the form ax plus by equals c. So I've got an x value, I've got a y value, but they should have coefficients other than 1, and I need a c. So let's do some manipulation. I'm just going to just write that over here so I know what I'm heading towards. I need an ax plus by equals c. So let's do some algebraic manipulation. First of all, I'm going to get rid of the 3 off the bottom on the right hand side. I'm going to multiply everything by 3. And what I get then is 3y equals negative 4x plus 19. I'm going to move the 4x over to the other side. It's negative on this side, so it's got to be a plus on that side. So I get 4x plus 3y equals 19. And now my answer is in this form that I wanted. So it's just a bit of algebraic manipulation, which hopefully you should be pretty good at by now. In terms of where your marks come from, basically getting the full equation in any form, so that's that thing there, he said is an achieved mark, and getting it into the correct format is a merit mark. 2C. So this is a solving question where you just need to substitute in the 50 in the right place. So it's telling you find when the temperature equals 50 degrees. Capital T is the temperature, so we're going to put the 50 into there and solve it to find out the time. Sorry, I've written it 6 seconds, but in fact, it tells us that our units are minutes. T is the time in minutes. That's an achieved question. Notice that I worked with T on the right-hand side until I got my answer. There's no problem with that. If T starts on the right-hand side, you can work with it on the right-hand side. I normally always will because it means that I'm doing less movement, less manipulation. All right, we've got here, sketch this parabola, labeling the vertex, the axis of symmetry, the x-intercepts, the y-intercepts. Now, there's a couple of different ways we can do this. The first way, which is the long way, is we could create a table of x values and y values, where y is x squared plus 6x, sorry, x squared minus 6x plus 5. So we would chuck in a bunch of x values. I'm just going to start with -2, -1, 0, 1, and 2. We substitute those in here. So -2 squared minus 6 times -2 plus 5. That's going to be, we grab our calculator. This is why this one takes a bit of time, but you've got plenty of time in your exam if you want to. So -2 squared minus 6 times -2 plus 5, and that gives a value of 21. And we continue doing that for the next few values. So I've just skipped ahead and filled in those values. I'm going to plot those. So the first one I'm going to do here is at -2, 21. I can't do that because it doesn't go far enough. In fact, I can't do the next one at -1, 12. My grid's not big enough. But this one is 0, 5. I can plot that. So when x is 0, y is 5. That's that point there. The next one, 1, 0, and the next one, 2, -3. I can plot those. So 1, 0, and 2, -3. But I don't have enough information to draw the shape as I should. So I'm actually going to have to do a few more here. I'm going to do 3, 4, and 5 and see if that gives me something useful. So having calculated those, you can see I have got some more useful stuff. So when x is 3, y is -4. When x is 4, y is -3. And when x is 5, y is 0. And I can see a symmetrical shape, so I could do that, which means I could now sketch this shape. So it's going to come down like this, and you're just going to do your best to freehand following those marks. It's never going to be perfect. Just don't keep going over it and over it and over it, because then you make a real mess. And it says I need to label the vertex. Here's my vertex. And I would always tend to write the coordinate if I know it. So the vertex is at 3, -4. It says the axis of symmetry. So I'm going to just do that with a dashed line. And I'm going to say that's the axis of symmetry. And the x intercept there and there. And you should probably label what those are. So this is at 1, 0, and this is at 5, 0. And the y-intercept is here. I'm going to label that as y-intercept, and that is at 0, 5. So I've done all of the things that it asked me to do, but I've done that the long way. There's another way that I could do that, and that is by knowing how graphs work when I can factorize them. So I can see if this can be factorized. So I'm just going to remove all of the stuff that I've already put there and show you the second way, which I think is the preferred method if you know what you're doing. The method I've just shown you is the way to do it if you're a little bit unsure. So what we're going to do in the second method is we're going to factorize y equals x squared minus 6x plus 5. We're going to see if we can factorize the expression on the right hand side there. And it turns out we can. And then we think, if I had to solve this when this equals 0, that's going to give me my x-intercepts. So the x-intercepts happen when, sorry, those should be negatives when I factorize it. The x-intercepts are at +1 and 5. So I can now go mark that on my graph at +1 and at 5. And now I know because this is a parabola, it must have an axis of symmetry that runs directly between those. So that is my axis of symmetry. So I've drawn that and labeled it. I can actually tick that off because that one's been done. I've got my x-intercepts. X-intercept, so I can label those. There's one there and one there. That part of the job is done. I now need to work out where my vertex is going to be. Because the coefficient of x squared just there is a hidden 1, when the coefficient of x squared is 1, I know that from the vertex of my parabola, if I go out 1, I go up 1. If I go out 2, I go up 4. And when I look at this from my the distance from my axis of symmetry to my x-intercept is 2. So I've gone out 2, which meant I had to go up 4. So if I come down 4 from there and go into the center, that is my vertex. And I can label that. So that's at 3, -4. And now I just need to use my knowledge of parabolas to mark in the other points. I go out 1, up 1 each way, and I go out 3 and up 9 each way. And then I can freehand sketch where that goes. And I've just missed, but it's actually okay because I've marked in where the point is. And I think that what you need to do there is you go y-intercept and you can write down what that coordinate is, which is at 0, 5. And by doing that, you've clearly shown the marker where you're supposed to be. You could also try and sketch it onto it like that, but often we end up making a bigger mess. So if you're pretty close and you can show the marker in another way what you needed to do, then you're going to get away with it. So now I've done the full thing that it wants me to do. In terms of marking, if you got 2 of those things correct, they'll give you an achieved mark. If you got all of them correct, they're going to give you a merit mark. On to question 2e. We have to solve this question and use the x values to find the smallest value of y equals that. So basically, we're trying to find the point where the vertex. So the first thing to recognize in this question is that it's a quadratic, even though it doesn't quite look like it because of this extra term here. When we expand out the brackets and then simplify, we're going to see that it is a quadratic. So I need to make that into a simple quadratic equaling 0, so that I can find out how to solve it, where the vertex is, and then go from there. So I'm just going to work with the expression on the right hand side. That's all I need to work with in order to solve this. So I'm going to expand this bracket out. So first values, outside values, inside values, last values. Two x times x is x squared. 2x times 3 is 6x. 5 times x is 5x. 5 times 15, sorry, 5 times 3 is 15. And then the value that I haven't touched on the end is still there. And now I can simplify that by gathering like terms. 2x squared plus 13x plus 15. And I'm going to solve that, so I'm going to make it equal 0. So in order to solve that, I need to factorize this. The coefficient of x is 2, which is a prime number, which means it's got to look like that. The 15 can come from a 3, or it can come from, 3 times 5 or 1 times 15. We need to try them. I'm going to go with a 3 times 5 first of all. I'm going to try putting a plus 3 there and a plus 5 there. And if I expand that out, I find, if I do it by testing, I'm going to get 2x squared plus 10x plus 3x plus 15. These two here are going to come together to make the correct 13x in the middle. So I have, on my first attempt, got the correct value. And if you were doing this in your exam, I would suggest that you do that little bit of testing work out here somewhere. That you can always just square off a space and use it for working, or do it on the back page. But doing it on the back page, it's kind of a long way from where your thinking is. So now I've got that, I can see that x equals negative 1.5, or negative 3 over 2, and it equals negative 5. That's where I solve them. So thinking back to the previous question, where we had to look for axis of symmetry in the vertex, the vertex of this is going to be halfway through those. So the vertex is when x equals negative 3.25, which is halfway between negative 1.5 and negative 5. If I know where the vertex is, because I know that my parabola is going to look something like this, I want to know what this lowest value is here. Let me just make that slightly better. I want to know what that lowest value is there. I know that it's at negative 3.25. I don't know what the y value is. As soon as I've got the y value, I know what the lowest value of y is. To do that, I simply substitute in x equals negative 3.25 into my answer, into my original expression, which I can do either on my expanded version, my simplified version, or the beginning. So I could substitute it into this expression, or I could substitute it into this expression, or I could even substitute it into there. They're all going to give me the same value. So I'm going to work with the original one up here. So I'm going to go y equals 2 times a negative 3.25 times a negative 3.25 plus 3 plus 2 times negative 3.25. And we'll put that into the calculator. I've missed something out there. I missed a plus 3. I'm just going to tidy that up a bit here. Should have been like that, so let's go and fix that up in the calculator. Add a plus 3 into there. And I get negative 5.625. Let me just double check that I put that in correctly. No, I haven't. Where I made that change in here, that should have been a plus 5. So in my calculator, let's go back and redo that. Negative 6.125 is the correct answer there. And for that question, they would give you an achieved mark if you expanded it and simplified it, so that's there. You'll get a merit mark if you solve that, and you'll get an excellence mark for finding that minimum value. All right, let's move on to F. So this is a distance time graph. It talks about a small insect traveling north, and all of the direction it travels is north, so it's just the distance away from its origin. It says at time 0, it is traveled 0 distance, and then it says travel north for 1 second, at 1 centimeter per second, so that takes it to there. And then for the next 2 seconds, it's going to cover 2 centimeters each second, so that's going to take it to there. And then for the next 3 seconds, it's going to go at 3 centimeters per second, so that's going to go from here to there. And then for the last 4 seconds of travel, it's going at 4 centimeters per second, so that's to there. I can't make that straight line click to the right place. There we go. So its total distance traveled is 30, which means that half of that is here at 15. And we need to work out algebraically what that time is. I can see when I look at this that it's at about 6.25 seconds. So reading off the graph, I think it's going to be about 6.25 seconds, but the question says show algebraic working in your answer. So we need to actually do algebra. So when I look at this, this is on the section of graph, as I see it, between 6 seconds and 10 seconds when it traveled 16 centimeters over 4 seconds. So the gradient for that line there is rise over run, which is 16 over 4, which is 4. So the gradient is 4. And we can work out the equation of that line as well using that by substituting in either this value here or this value here. So I'm going to go with this value of 1030 and this gradient to calculate. So y equals mx plus c. So m is our gradient, so it's 4x plus c, and then I've got an x and a y value, which I wrote up there was 10, 30. So where the y is, I get a 30, and where the x is, I have a 10. So c equals negative 10. So the equation of this line is y equals 4x minus 10. And I now want to know at what value is x going to be when y is 15. So the question was asking us find the time. So let's make sure we've got units on there at 6.25 seconds. And they've given us a whole lot more working space here, which we don't need. So for question 3, the first 4 terms are those. We need to find an equation. So normally what we do is we would go x and y. I'm trying to find an equation which would be y equals something x plus or minus something. So I set this up. My x values are going to be 1, 2, 3, and 4, and the y values are 2, 6, 18, and 54. Now, when I look at this, I'm going to get a difference column, and my difference column is going to be 4, and then it is 12, and then from 18 to 54 is 36. So this sequence, when I look at it, is not linear, because if it was linear, those would be the same values. So let's have a look at the second difference. The second difference is 8 here, and it is 24 here. I was expecting the second difference to be the same, and it isn't, which means that we've got something that's probably an exponential. I think this is actually beyond what you need to know for this course, so you can have a go at it if you want, but I think that probably you won't be asked a question like this, because I think it's beyond the syllabus for this year. Effectively, what you're going to do is, if you look to get from 2 to 6, it's multiplying by 3, from 6 to 18 is multiplying by 3, from 18 to 54 is multiplying by 3 as well, which means that we, instead of having what I thought we've got something where we've got 3 to the power of x. Now there might be some other stuff where I put those lines there, so we need to check that out, and there could be something added on the end. So if I go back to my table here, like I say, don't worry if you don't understand what's going on here. I'm just going to rub out those columns, and let's have a look. Let's see what 3 to the power of x is. So 3 to the power of 1 is 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27. So these don't work. So we need to do something else. Let's just trial and error a couple of things. What if I did 3 to the power of x minus 1? So 3 to the power of 1 minus 1 is 1. 3 to the power of 2 minus 1 is 3. 3 to the power of 3 minus 1 is 9. And then we get 27. And I can see a relationship now between these y values and these ones here. The y values are 2 times that. So that means that my finished expression is y equals 2 times 3 to the power of x minus 1. Now, don't worry about this question at all. I really do think it's beyond what you need to, and he's marked that as an achieved question. I think that is far too harsh for the year 11. Right, the next one, the sides of a right angle triangle are x, x plus 7 and x plus 8, form a quadratic equation and solve it. So I'm going to draw that. As the first thing we should always do is draw things when we can. So I've got a right angle triangle. The x plus 8 must be the long side. This one is x plus 7 and our shortest side is x. And Pythagoras says that this square plus this square equals that square. So let's write that as an equation. So square 1 is x times x, or x squared. Square 2 is x plus 7 squared. And that's going to equal the big square, square 3, which is x plus 8 squared. And it says to form a quadratic equation and solve it. So a quadratic equation that solves has to be equal to 0. So I need to expand these out and simplify them. Now that I've got them expanded, let's get them all over to the left-hand side. So we've got 0 on the right-hand side. So I'm going to subtract that x squared there, which means I have to do it there as well, and that's going to do those. I'm going to do this all on one line, but you may want to do it on several lines. Subtract that 16x there, and I'm going to subtract that 64 there, because they're all positives on the right, so they're going to be negatives on the left. So 2x squared minus x squared is x squared. 14x minus 16x is negative 2x, and 49 minus 64 is negative 15, and that equals 0. And now I need to factorize that. So two numbers that multiply to make 15 and add to make, multiply to make negative 15 and add to make negative 2 are going to be negative 5 and positive 3. So that means x is going to be 5 or negative 3, but x can't be negative. So that means that x equals 5 centimeters. Next question. Andrea is 6 years older than her husband Blake. She also says she is 15% older than Blake. So let's call Andrea X and Blake can be Y. I like to work with X's and Y's. You could work with A's and B's if you wanted to. So Andrea X is 6 years older than Blake, and she is 15% older than Blake, so 1.15 times Blake. And we need to now solve those. What that means is that if x equals x, those x's are the same, that's Andrea's age, then y plus 6 must equal 1.5 times y. Y plus 6 equals 1.15 times y. And let's solve that. So grab my calculator for this last step. So Y is 40, and we need to solve for their ages. So Blake is 40, Andrea is 6 years older, so Andrea is 46 years, Blake is 40 years. And for that kind of thing, you should just simply write your answer in a sentence. It takes care of it nicely. So let's move on to D. So in this question, we need to come up with a formula for the area that doesn't have two variables in it. So the formula up the top there has two variables in it, but we can't work that out given that they've just given us a value for the area. So what we need to do is we need to think, what else have they told us? There's a really key thing here where they've said the base is 10% wider than the height. So base equals 1.1 times the height. 1.1 being an increase of 10%. And then the other piece of information we've got here is that the area equals 2/3 base times height, and that the area equals 165 centimeters squared. Those are the key pieces of information, and we should also make sure that we're aware that what we're trying to find here is the dimensions of B and H. That's what the final answer should be. So let's do some work on these. What we can do is we can take this expression for B that we've got and we can put it into our area formula. So we can now say that the area equals 2/3 times 1.1 times H. And when I'm inserting something or substituting in, I always use brackets, times H. And let's just simplify that. So area equals, let's do our 2/3 times 1.1. 0.733, and I've got times h, which is h squared. And it tells me that the area is 165. So 165 equals 0.733 h squared. So a little bit of algebra work on that. H squared equals, I'm going to do 165 divided by the answer that I just had. Remember that that answer function in your calculator is a really good one to use. And that gives me 225. If I didn't use that answer function, I would probably find that I don't get a whole number. So h equals the square root of 225. Which is 15, but you should double check that with your calculator. So h is 15. Let's just go back up here and check. We're working with centimeters. So h equals 15 centimeters. And I also earlier wrote this expression here that says that the base is 1.1 times h. So b equals 1.1 times h, which in this case is 15. So b equals 16.5 centimeters. In terms of your marking schedule, he has said that being able to form the equation here that's achieved and getting both of these correct is merit. On to E. In order to do this question, we need to be able to know a bit about exponential graphs. So I'm going to just do a quick explanation of exponential graphs, but really you want to go and look these up elsewhere, find out how to do them. I'm sure there'll be work on Infinity Plus One YouTube channel for this, or you can do some searching elsewhere. If you want to look at old exam papers that would have exponential graphs, you want to look at the tables, equations, and graphs standard from the old level 1 NCEA standards, and there's definitely a lot of work on the Infinity Plus One YouTube channel for that. So what I've got here is a graphing window for Desmos, and if I do what we consider to be the most basic exponential graph, it would be y equals 2 to the power of x, and we can see that there is a curve there, and the curve goes through the point 0, 1. And it actually never ever, if I zoom out on this, if I zoom out and zoom out, it's never going below that x-axis. So the most basic curve here never goes below the x-axis. If I change that base number here to a 3, you see a similar thing happens. If I change it to a 10, a similar thing happens. The only thing that's changing when I'm doing that is that the curve is getting steeper. If I go back to 2 here, it goes through 0, 1. When x is 1, 2 to the power of 1 is 2. I get that value there. When x is 2, 2 to the power of 2 is 4, which is here. When x is 3, 2 to the power of 3 is 8. So I get up here. So this graph can be manipulated a little. If I was to add a value onto the outside, let's say I was to subtract 3, it moves the whole graph down 3. If I was to change it to a plus 4, the whole graph goes up 4. So we can see that the graph shifts up and down based on that. And if I was to, within the power, subtract 2, sorry, I'll put some brackets around that so it stays there, subtract 2, that's shifted this point that is 1 above the x-axis 2 to the right. If I was to add 3 in there, it shifts that point that's 1 above the axis 3 to the left. So if we go back to our standard exponential curve, I'm going to use 2 to the power of x. It always goes through a point 0, 1, and it actually doesn't matter what the base number is. So we can use that as a way to find out what kind of curve we've got and where it's been moved to. And then we can look at when x is 1, what is the y value to find out what the actual base number is. So let's go back to our question we're working on. So we're given 2 possible equations for the graphs. Based on what I just did, we can see that equation number 1 is a graph that's been moved up or down because of the number out there. So this is an exponential graph that's been moved up or down. And because of where the b is here, that's a graph that's been moved left or right. So if we look at, I'll put a 2 there, if we look at our 2 curves, the one that I've just put a 1 next to has been moved down, and the one that I've put a 2 next to has been moved across. So it says we need to find the values of A and B and the points where the horizontal line intersects the 2 curves. So how far has the first curve been moved down? So this point here, we would have expected to be up there. So it's been moved down. So I can say that A equals 2. In the next one, we need to look at where the point that should have been here has moved to. And it's moved to there. It's moved 2 to the right. So B is, B is also 2. So we've done the first part of this question. The second part of the question is finding where the horizontal line intersects with the 2 curves. So if we look at that horizontal line, we can see that It goes through the point where y equals 2, and because it's horizontal, that means it has no gradient. It's just a constant of 2. So the equation of that line is y equals 2. So in equation number 1, we find that it's pretty straightforward because we can actually virtually see that that is where x equals 1. And we can actually just test that, and that would be fine for that. We could say, what happens if y equals 4 to the power of x minus a? What if x is a 1, y equals 4 to the power of 1 minus, and a here is that 2. That's going to give us 2. That's exactly what we want. So the coordinate in this equation is at 1, 2. In the second curve, it's a bit harder because we can see that it from the point there, it drops down somewhere between 2 and 3. Now it's probably 2.5, so you could do that with guess and check, but I suspect in this case they want you to be a bit more clever about it. So we're going to take the equation of the second curve, which is y equals 4 to the power of x minus b, and remember b was a 2. And we're going to put in our y value of 2 from the horizontal line. So 2 equals 4 to the power of x minus 2. Now the reason I think they want you to do it this way is because this looks like the kind of thing that we can solve by making the bases the same. So 2 equals 4 can be rewritten as 2 to the power of 2, all to the power of x minus 2. Now, according to our exponential rules, that means 2 equals 2 to the power of 2 times x minus 2, and that's 2 to the power of 1 on the left-hand side. So 1 equals 2 to the power of x minus 2, because if the bases are the same, then the exponents must be equal. And now I have to solve that. And x does in fact equal 2.5. So at this one, it is at 2.5 and 2. So this is an excellence question. You're going to get an achieved mark if you work out what A and B is according to him. You're going to get a merit mark if you do that one, and you're going to get an excellence mark if you do this with this algebraic working. Without the working, you would still just get the merit. All right, and on to the last question. So in this question here, they give us a few interesting pieces of information to help us work out how to do this. They tell us the height of this is 3h, and they tell us that the radius of the base is 3x. So what I've drawn there, if I include that side there, is a right angle triangle. So that right angle triangle is 3x there and 3h there. Now, using the properties of similar triangles, if I was to look at the triangle on the second level there, that's going to have a radius of 2x and a height of 2h. So that's going to look like this. Because if the base side is 2/3, then the height will also be 2/3, and using the same logic, the top triangle looks like this. Now if we go and look at our formula sheet, we can see what uh, the volume of a cone formula is. That's actually right there for us. So the volume of a cone, I'm just going to put this up here because I'm going to use it down the bottom soon, is 1/3 pi r squared h. So I've just put that out to the side of the cone there. So the question's asking for the ratio of the volume of the smallest piece to the volume of the largest piece in its simplest form, which means that in actual fact this middle triangle here we can ignore. We're only working with the smallest and the largest. So let's write down the volume of those two using the h and the x that we know. So the volume of the large one is 1/3 pi, the radius is 3x squared, make sure that's in brackets so you don't miss that out, and the height is 3h, and the volume of the small one is 1/3 pi r, which is just x squared, times the height h, which is capital H. I'm just going to do some simplification of the large one. The 3 on the bottom and the 3 on the top cancel each other out. The 3 squared becomes 9, so I've got 9 pi x squared h, and the small one can't be simplified from what it is. So just rereading the question, I've realized that the volume of the large piece is probably actually referring to, if I use just a yellow highlighter, it's probably referring to this piece here with the top part removed. So I actually did in fact need this second triangle here, because the volume of the large is going to be what I've already written down minus the volume of the second piece. So that's going to be 1/3 pi r, which is 2x, times the height, which is 2h. So again, I'll do some simplification here. I've got 9 pi x squared h minus 1/3, 2 squared is 4 times 2 is 8, so I can actually change that numerator there to an 8 because 1 times 8, 8/3 pi x squared h. So that's actually my volume of the large. And then the volume of the large is 19/3 pi x squared h. Now when we're simplifying ratios, we can do it a little bit like we do with fractions, so we can get rid of things that are similar on each side because they cancel out. So the h's cancel out, the x squareds cancel out, the pi's cancel out, and now we're left with 1/3 to 19/3, which if I multiply both sides by 3 is 1 to 19, and that's our final answer. So if you get in terms of marking either that volume or that volume correct, that's achieved, so a volume of one of the bigger squares. If you get to there, that's going to get you a merit, and if you get to there, that's going to be an excellence.